jailbroke and hacked our PlayStation 5 and put Linux on it. And to add insult to injury, we played Halo Combat Evolved on our PlayStation 5. Although this content might piss off some of the bigwigs at a console manufacturer somewhere, our lawyers have told us that we're in the clear and we can publish this content. And also, for a second point, it's not Nintendo, it's Sony. But we'll see if this video gets Bloomberged anyway. InfoSec engineer and Sony exploit finder Andy Wen, aka The Flow, recently published a method to load Linux on a PS5. And like a lot of the best weekend projects for nerds, we didn't have a lot of reasons to actually do that. Except that it's fun. And sometimes it pisses off the console manufacturers. But mostly it's fun, and that's enough of a reason, because god damn it, sometimes it's okay to have fun with hardware. What you're looking at is Linux on our original PlayStation 5 that we bought and tested years ago. This is a soft mod that boots Linux from a storage device without permanently altering the console. Once it's running, it acts like a normal Linux desktop, including the ability to install Steam and run games. This isn't technically the first time that PlayStation 5 APUs have run Linux. ASRock sold BC250 systems for mining that were reportedly based on defective PS5 APUs, but this mod allows running Linux on a completely normal, sold by Sony PS5. All of this required jailbreaking the PS5, buying the cheapest router we could find locally, running an HTTPS server and fake DNS on an ad hoc laptop as a server, and then delivering the payloads to the PS5. We're gonna walk you all through it and test it. Today we're not focusing too much on the benchmarking, just on getting this working at all, to do that behind me. And we have a couple benchmarks in here, but this opens the door for lots of interesting tests and academic kind of exercises if people are interested in it. So we'll keep an eye on the comments, but we're focusing today on how to get the hack with the PS5 from the Flow's mod working. Let's get into it. Before that, this video is brought to you by Thermaltake and the TR200 WS Micro Chassis, a Micro ATX stout case. It includes an optional 5 1/4 bay for either a screen or 5 1/4 drives. The case has a highly perforated side panel, a color accent front styled like other popular cases, can fit radiators and closed loop liquid coolers in the top, up to 360mm claimed support, and a total of 7 120mm fan mounting locations between the top, bottom, and rear of the case. Max CPU tower cooler clearance is claimed at 175mm and GPU clearance at 365mm. The chassis provides a portable, highly compatible box for your builds. Learn more at the link in the description below. So some complications right away. At the time we were working on this, writing this, only some PS5 3.x and 4.x firmware versions are actually supported with this. Now, fortunately for us, this has been in a storage closet for like 5 years. And so it had an old enough version of firmware that we could run the tests on. The one behind us hasn't been. That one was updated last year. Couldn't use it for this because it had received an update automatically when we turned it on last year for other testing. And another complication is that between 3.x and 4.x versions of firmware, only the 4.x versions support using the PS5's internal M.2 storage, which is why we have this dangling out of the front of it, because ours is on the sub 4 version of firmware for this mod to work, and so we did everything on here. This machine we ran thermal benchmarking on at launch, and then we basically shelved it because we try to preserve things like this for future regression testing or interesting abnormal tests in the future, and we have found the interesting future abnormal test today. As far as this sort of thing goes, the process was actually pretty simple, but it still took us a couple days. First, we threw Debian on a test bench to make setup easier. It's possible to use WSL, or Windows Subsystem for Linux, but we didn't want to deal with that on top of everything else. We were then able to clone the Linux image, specifically Ubuntu 26.04 long-term support, or LTS, although there's also support for 24.04 for Arch Linux and for Alpine. The Flow's README specifically walks through an Ubuntu install, so we followed that. We've done some Linux benchmarking over the past year or so, including Bazite, for example. We were interested in Arch here, but Ubuntu had the most documentation. It seemed to be the default choice by the developer, and so we followed the path forged by the developer. Even with that, we tried to build the image, failed, and then basically kept trying until it eventually worked. Kept installing packages, and then it all started functioning. But even then, it took a while to build, so we left it running overnight. Next, we flashed the image to a USB drive, which in our case was a Samsung 980 Pro M.2 SSD in an ROG Strix Arion external enclosure. Since our firmware version wouldn't have internal M.2 support, we needed something that was fast enough to work well over USB Type-C. And we also can't really update the firmware on this, at least not in a kind of controlled way, because then this mod won't work at all. There's not an easy way to jump to a 4 point something from a 3 without going all the way to the newest, where then this is all just broken. On the console end, we changed the power and HDMI settings on the PS5 as per the PS5 Linux README. Then we needed to run the UMTX jailbreak exploit, which is a general purpose tool that has been iterated on by multiple developers. This isn't part of the Flow's PS5 Linux project, it's just the tool for getting it loaded. In order to get that working, we also had to buy the cheapest functional router that was available nearby, so I gave Patrick the credit card and asked him to go find something for the project, and he came up with a solution to build an ad hoc at-home server.
Okay, so for our PS5 jailbreak, we've got a laptop running right here to start with. So this has two things running on it. It's got a fake DNS server and it's got an HTTPS server running at the same time. The fake DNS server, we have to set up the PS5 so that its DNS settings are pointed at the IP of the laptop. And then the HTTPS server is hosting a web page that will pop up on the PS5. So both of those pieces of software are running right now, so we can go ahead and turn on this PS5 here. So this is a 1080p screen. That's intentional. We were having some compatibility issues with the Linux setup and higher resolution screens, so 1080 is just the most compatible, easiest way to handle this. So here we are. PlayStation OS, this is not Linux, it's a BSD, and it's operating completely normally. This is how we left it years ago. So if we go into our settings here, now that the PlayStation has started up, we can see user's guide, health and safety, and other information. So normally, when you select this user's guide, this brings up a web page that Sony hosts. But because we've tricked the PlayStation, we've pointed the DNS server at the laptop, now we can select this user's guide and we say that the security can't be confirmed. That's okay. And we get this jailbreak page instead. So this is the web page that's being hosted on the laptop, basically. And if we select jailbreak here, now we have run the jailbreak. So that's all it is. It's a soft mod. Theoretically, nothing is permanently altered on the PlayStation. You know, we're not the developers of this mod, so I won't swear to that. But these are the default payloads that are built in. So as it is hosted on GitHub, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 different things we can select here. None of those are the payloads that we need in order to load Linux. So in order to do that, again, we go over to our laptop and got netcat GUI running here. It's pointed at the IP of the PS5 on the local network and the port of the PS5 on the local network. So we actually could have hooked everything up here to our actual network. Again, I don't think internet access would be a problem since we have updates turned off. We didn't want to do that. All of this stuff is public. Other people have used it, but we didn't feel great about running exploits and jailbreaks and stuff on our actual network that we need to do work on. So we went out to Office Max and bought the cheapest router we could find, which was $90. Routers aren't cheap anymore, or at least they aren't at brick and mortar stores. And we set up a local network here. This router's never been connected to the internet, but we've got laptop connected to router, router connected to PS5, PS5 video output going to the capture card connected to the laptop, and then pass through from the video card going to the monitor. And then we've also got this external drive here with our Linux install that we set up earlier on it. And we've got mouse and keyboard hooked up to the PS5 through a hub. Because none of the onboard peripheral stuff works, we've got this USB network interface card here that we're going to use to connect to the internet once we're in Ubuntu. And yeah, we need all of this together in order for it to work. So in Netcat GUI, we can just inject payload here. And if you look at the screen over here, when I hit that button, we have finished preparation. We are going into rest mode. So all we have to do now is wait for the orange light to stop blinking. And I'm going to connect to the internet now because theoretically we're in Linux land and Sony can't hurt us. It shouldn't be an issue now. We're not touching anything Sony, we're not touching anything PlayStation other than the hardware. So orange light is blinking. Okay, so we've got a solid orange light now. That means it's in rest mode. And we hit the power button here to boot it back up. And we should be in Linux. Yep, so okay, we've booted up now and we're in our Ubuntu install that we set up. So we picked Ubuntu just because it was the default choice. That was what the walkthrough on GitHub was for. If we did this again, we probably wouldn't pick Ubuntu again. It's been a little bit troublesome, mainly just with the Snap package manager. Yeah, I think my worry is that somebody figures out how to, run an AI model on it, and then all the PS5s get bought out. We were talking about that the other day, where it's like, I guess Valve has said that they don't want to make the price, they don't want to take a loss on Steam machines, because then if everyone starts buying them for purposes other than running Steam, then they really are taking a loss on it. I don't know that Sony's taking a loss on PS5s at this point, but it would suck for everyone if everyone started buying them to. This is all set up and ready to go now. This is just a normal Linux system, and we can get on with the rest of our testing.
Now, we could have just plugged everything into our normal network instead of buying that separate router, but that seemed like a bad idea for multiple reasons. One, we wanted to really make sure that this was disconnected from Wi-Fi, because we had previously been connected to the Wi-Fi here, and so we didn't want it to auto-update. Secondly, hardware bans. We didn't want it to phone home anywhere. So we built a fully contained local-only network. We connected the PS5 and a laptop to our new router, ran the fake DNS tool from IdleSauce on the laptop, ran an HTTPS server on the laptop, and changed the PS5's DNS settings to point to the laptop's IP. This replaces the PS5 user guide webpage with our own HTTPS server, which is used to deliver payloads to the PS5. Of course, that didn't work at first, so we had to disable multiple Windows services on the laptop as per IdleSauce's guide. There's several payloads baked into the page, but the Flow's PS5 Linux loader.elf isn't one of them yet. Instead, the tool also keeps the PS5 listening on a port, so we had to figure out a way to deliver the .elf file through that. The Flow offers zero guidance here, but we were able to find a version of the Netcat GUI that worked, which made it as simple as picking an IP, a port, and a file. Leave it to Linux and the Linux community to have things named Netcat, Elf, and IdleSauce. Successfully sending the file kicked the PS5 into rest mode automatically, after which we just turned it on and booted into Linux. Pretty cool. Unfortunately, display compatibility is spotty, so we had to swap out the Asus TUF 4K screen that we had bought for other projects with an ancient 1080p display that we had lying around. By the end, we had a laptop connected to a router connected to a PS5, PS5 outputting display to a capture card, and a capture card passing through to a monitor. The mouse, keyboard, Linux drive, PS5 controller, and various power cables were all hooked up and all working. Now that's most of what we were interested in, and it was successful. It loaded, it did that. It's not meant to be a benchmarking piece, but we did a few benchmarks just for fun, because the unique thing with this is that you can just run Linux tools. And so we ran Mango HUD to get a performance ballpark for some of this. And again, there's a lot more we could do with this benchmarking wise, but we wanted to kind of like get it started, throw it out there, see what the interest is. And we'll consider if there's anything else to do here. The Flow also hosts tools to boost the fan curve and the boost clocks. If enabled, clocks are increased to 3500 megahertz on the CPU and 2230 megahertz on the GPU. Effectively, we overclock the PS5 by doing this. You can also manually change the VRAM allocation, but out of the box, it's supposed to dynamically split memory between the CPU and GPU, so we left that setting alone for our tests. The VRAM adjustment though, like the overclocking, could also be really interesting for some academic exercises, because consoles, the whole kind of concept is that they can be tuned and adjusted for a specific set of hardware that millions of people have identical copies of. And so if you start getting into desktop PC video game VRAM optimization versus console, these types of settings will let you play around with and explore some of those concepts. Anyway, the point is there's a lot of other cool stuff that can be done here from a research standpoint, but let's get into some of our tests, and we'll start with Halo on the PlayStation. We wanted to live the dream and play Halo on a PlayStation, so we started with Halo Combat Evolved in the Master Chief Collection through Steam. Added to the list of cool fun shit you could do with this. We've installed Steam on a PlayStation. We had a ton of hitching problems though, as well as some crashes and failures to launch. But with the graphics set to the enhanced preset, the game was technically playable. We even left anti-cheat on, the default setting, with no modification. Average FPS was 91, not bad, with a 0.1% low of 10.4, very bad. And that reflects the annoying hitches we got in the game every few seconds. The lows here are god-awful, which maybe isn't a surprise given how hacky this whole thing is. But that's the point of it. It's not a good experience, but it does work, and it could be improved. Using the flows tools to boost the fan curve got the average up to 93 FPS, and boosting the clock speed, so overclocking the PS5, got it up to 95 FPS. That's a 5% uplift versus baseline, although the hitching remained a problem. We wanted to test a true 100% PC game as well, something that made no sense on a console. So we picked Stellaris. And then we found out that Stellaris has a very well-liked PlayStation port. Go figure. We're PC gamers here, so I mean, but we picked Stellaris anyway. And the difference for ours is we got to run the Steam version of it. We were getting worried about how warm things were getting here, especially after how connected flash drives were nearly burning hot to the touch. So we kept the fans boosted for all of our other benchmarks. With the fans boosted, average completion time for our tests was 117 seconds, and with the clocks increased as well, that dropped to 108 seconds for a 7% reduction in the total simulation time required. Just for comparison, our most recent CPU test suite had the R5 2600 at 89 seconds and the R7 2700 at 88 seconds. That said, these aren't like for like, given the OS differences and also the difference of literally all of the hardware, but it helps for perspective. Now, there was a lot of speculation about Crimson Desert's performance on the base model PlayStation 5 at launch. So we went ahead and ran our own benchmarks with the cinematic preset. We saw a lot of issues, like muddy textures, brutal popping, gaps in geometry, magically appearing pumpkins, and insanely long load times. But we did manage to get it running. We even captured one of our load times and clocked it in at 97 seconds. All that's to say, take the numbers with a grain of salt, since the game isn't working quite right. Crimson Desert might benefit from manually tweaking the VRAM allocation as well, but we'll save that for another time. We saw the same hitching problems that we did with Halo, but not constantly. Average FPS with just the fan boosted was 35. And with clocks boosted as well, that rose to 37 for a 6% improvement. The lows were overall better with clocks boosted, but even with the boost, we had an individual run with significant hitches. We also ran the free version of 3D Mark FireStrike through Steam, but it's absolutely not intended to be run this way. On Linux, through Proton, and on a PS5. So our results were inconsistent at best. The highest score we got was without fan or clock boosting, and it landed at 15,939. So that was 21,731 points for graphics, 14,713 for physics, that's the CPU only test, and 5,546 for combined. For reference, an R5 1600AF score I randomly pulled from the 3D Mark database was at 18,074 points for the physics score. That's the CPU score, as compared to 14,700 for this PS5. We also found a GTX 1070 with a graphics score of 22,217, which is almost an exact match. But again, to be clear, because there's gonna be a lot of very angry console people now. Just look, the numbers are what the numbers are, all right? Be very clear, this is not the PS5 running at its best. It's running an unsupported operating system with an unsupported benchmark tool, putting out to unsupported displays sometimes. The point is, not the best way to test it because it's no longer a PS5. You kind of lose like most of the optimization. It's a Linux machine. It's not a PlayStation anymore. But those are what the numbers were, if you were curious. And I can't wait to see the comments and the angry Reddit threads. But that's what they were, all right? Okay. If we take the developers at their word, this is 100% a soft mod, meaning that nothing about our PS5 changes permanently. That's what they say. We don't have a great way to see that. We haven't connected this to the internet yet to see if it just gets like instantly hardware permabanned or something. But rebooting always kicks it back into the regular PlayStation OS. So we haven't lost that. We can still use it as a normal PS5. We just reboot it. Unplugging this, if you want to go a step further, makes it even easier. But we haven't lost the ability to use it as a PS5. Switching to Linux, again, requires running the mod and delivering the payload again. So those steps require repeating. Any changes made within Linux are saved, though. So that's useful. It behaves kind of like a computer, and it operates entirely on an external drive for us, which is why it saves it. If you have a 4-point-something version of firmware that supports the mod, you can do it on an internal drive. Same idea for all of that. Hopefully the level of separation eliminates the risk of a hardware ban. That's our hope. We can't guarantee it. I don't know. If you install this stuff on your own, it's possible they have a way to detect it that we're not aware of because we haven't connected to the internet, and maybe it does a hardware ban. But in theory, it shouldn't. We just can't commit to it. A lot of these console companies are sort of evil with how they treat people who play around with hardware that they bought and own and is in their possession. So they do exercise bans sometimes on the hardware level. Right away, the biggest inconvenience is that the PS5 only has 4 USB ports. One of them is USB 2, another is dedicated to the boot drive, unless you go the extra mile and move the OS to internal M.2 storage, which again we couldn't do due to our firmware version, and hubs are supported and are pretty much necessary. Now a lot of the PS5's built-in functionality doesn't work with this mod, so Wi-Fi, the NIC, Bluetooth, the controller's wireless, none of that works here. We had to find other solutions for it, and although that could change with future releases of the soft mod, as it is now, connecting to the internet requires a USB NIC. There are a couple of other quirks, so suspend and screensavers are not supported. Those need to be turned off and not used. Also, support for resolutions above 1080p are highly situational, so it's unreliable. There are troubleshooting guides on the GitHub page. We're kind of getting there. Patrick was getting close to figuring it out, but we're just having trouble getting 4K to run properly with this. And it does seem very display dependent as well, so your mileage may vary depending on the display that you have. 1080p was no problem for us, and resolution will also not change automatically when the monitors are hot swapped. So adding a 4K capture card into the chain also caused us problems. That's maybe not a normal use case, but that usually required turning the PS5 off and then going through the whole boot process again. It's been a long time since we used Ubuntu, so we weren't aware that the default Snap package manager sucks. The repackaged version of Steam that Canonical distributes is so broken that at least one Valve developer has publicly asked people to stop using it. Once we realized that was the reason that nothing was working and we had burned a whole day on it, we got rid of it. We tried to uninstall Steam and the games that we had already downloaded, spent all night downloading them, only to find that Snap automatically creates snapshots unless you use the purge flag, which again, I'm sure lots of people know this, but we didn't. And so that was something we had to discover in the process. We were trapped in an interminably long loop of the backup process, watching the disk slowly fill to the brim with extra copies of data that we had explicitly chosen to remove. So in other words, standard Linux experience for people who haven't had a lot of experience with Linux. To be clear, stuff like, there's a lot of Linux distros, they work great out of the box now, but it was some learning pains for us putting it on the PS5 specifically. We used Bazite most recently, so it was a much different experience. Anyway, it felt a bit like Windows, is what we're getting at here. Even though we were running everything off of an external M.2 enclosure over USB, we didn't directly notice any I/O speed problems. It's possible that it was the source of the hitching or the artifacting in games. It doesn't seem likely, but we also don't have a way to check it one way or the other, so it doesn't really matter. We could have manually updated the PS5's firmware to a version that would allow us to use internal M.2 storage. Technically, that's a thing we could do, but after getting everything working, we just weren't willing to risk causing an unforeseen problem, because if we screwed that process up at some point, or if it does something we don't understand, like auto poll something or update to the wrong version, whatever, it's over. Like it's not an easy way, as far as we understand, to then install this, because it requires an older firmware version. So we just didn't want to fuck it up, and we went with what was working. Now, maybe someone will come up with a practical use for this, or maybe someone will start sticking LLMs and AI on PS5s. You could probably boost Sony sales significantly. You could have the first AI PS5. Wouldn't that be great? You can use all the memory in it for getting your wrong answers, I guess. I don't know. But if you have a PS5 lying around with firmware that is multiple years old, chances are you're already doing some kind of modding or testing or game developing or something. And this is pretty easy and unrisky as a project to do for fun. Now, there is some risk involved, like with potentially getting hardware banned if they have some way to detect it. But again, everything we've seen indicates that's not a thing they can do. We just haven't gone through the test with that. So legally, we won't tell you that you should do what we just did here, but our lawyers have said that we can do it and we can make this video. We're not saying you should do it, but you could do it, and the tools are right there on GitHub. So this sort of thing, it can keep older hardware alive. And as consoles get increasingly online and phone home to servers and things, being able to jailbreak them and basically hack them in a way that is fully within your control, you're not stealing shit, you're just putting Linux on it. It's not really a big deal. And if you own the goddamn hardware, you should be able to do that. Like, you should have every right to modify it however you want. Just like if you have a router, you should have every right to install a different firmware on it, or a different OS, basically, on it for managing your router, your console, whatever the device is, because it's not hurting anyone, and you bought it and you own it, and that's how things should work. So as far as modern consoles go, being increasingly online, this type of mod can help keep them useful for things long term, and it can also open up a lot of doors for really fun, interesting projects, and again, academic research from an unironic perspective of understanding how games between console and PC perform from whatever, an optimization standpoint, VRAM consumption, things like that, because now you can test it on literally the same hardware, with the major difference being the operating system, and that matters. But that's also kind of what you'd be testing in that situation. So really fun project, really fun, just kind of like week or so of setup and testing. Pretty awesome to see this stuff work. You know, doing hacks like this, it's fun. And that's kind of the beauty of working with hardware on any level, because you can just do cool shit for sometimes no particular reason whatsoever other than it's fun. And yeah, that's nice sometimes. So that's it for this one. If you have ideas, do feel free to let us know. This is all still set up. We could do more with it, I guess, if there's really a big interest in it. We're not trying to do like a big just general console versus PC benchmark, but there's like really pinpointed things we could do as a study or something, then maybe we'll consider it. Let us know what you do with the project, what your ideas are. Please don't buy all the PS5s and put LLMs on them. That was a joke. I guess you could, but please don't do that. We have enough problems with AI, so we don't need more of it. I mean, the next console, probably the next one's going to be a PS6 AI version anyway. And I don't know what the AI will do on it, other than maybe it'll like shit talk for you in games or something, but we'll find out when we get there. Subscribe for more if you like this content and you want to support us and our ability to pay people on the team to dedicate like a week to it. Then you can go to store.gamersnexus.net and help us out there by grabbing one of our PC building mod mats. Our project and soldering mats remain awesome for all kinds of arts and crafts projects or just soldering, because they are extremely heat resistant silicone. And you can also grab some of our dice kits or other items on the store. Subscribe for more. Thanks for watching. We'll see you all next time.